When we talk about the risk of returns, that is associated with uncertainty. And perhaps the most common measures of risk, they focus on volatility. And what volatility captures is how much uncertainty, how much predictability, how much variability there is from year to year in the returns. So, for example, suppose we had annual returns of 4, 5, 4%, 7%, 4%, 2%, 6%. Those are relatively stable. There's not a lot of variation. They're more predictable. You can see pretty much every year comes up somewhere around 4%. You might have like 5 or 7 or 6 and be a little bit above. You might be at 2% and be a little bit below, but returns tend to be pretty stable from year to year, relatively predictable. Suppose you have another asset or another investment and had annual returns of 4%, then 15, then negative 14, then 27, then 14, then negative 22, and then 16%. Those would be relatively volatile. They vary a great deal. One year they're up, the next year they're down, and they're much less predictable and less certain. When you can go from one year from negative 14 and then jump up to 27, down to 14, and then down to negative 22, they're really bouncing all over the place. So that's what we mean when we talk about volatility and unpredictability. And so basically, these are not very volatile and these are relatively volatile. How do we measure volatility? The two most common measures are variance and standard deviation. And in our discussion, we're going to focus on the risk and volatility of returns, but the discussion on risk and volatility, it's relevant for any random variable. We're just talking about returns, but for any variable that's random, you can apply the same statistical notions that we'll be talking about. So what is variance? It's the weighted average of the squared deviations from the mean. And so we'll talk about what all that stuff means, but what it really does is it captures a tendency. So it's one number that tells us a lot about the tendency, about an asset or returns behaviors, how they tend to deviate from the average return. So you've got a bunch of returns, you find the average. Does any individual return tend to be similar to that average, or does it tend to be different than that average? Higher variance is associated with a greater tendency to be different than the average. So if you've got some returns that are really high and some that are really low, they might tend to deviate. Those would deviate a lot from the average, so you would tend to have higher variance. Lower variance is where the individual returns tend to be quite close to the average, and there you have low variance, low volatility. One of the ways you can think of about variance is the standard squared deviation. So we're going to talk about this in a second, but what do we mean by deviation? It's the difference between an individual returns and the mean. We square them, and then we find the standard one. So it's a way of thinking about variance. It'll become more apparent when we get into the equation and how we apply the equation. So here's the equation, and I'm going to walk through it in a minute because a lot of students generally don't like the equation. So let's just jump ahead and come back. So here's how you could estimate the variance of returns. Again, we want a deviation. So the deviation from what? It's the deviation from the average, the deviation from the mean. So step one, find the mean. And the mean is just a classic average. So you can add up all the returns and divide by n, which is the same as weighting each of the n returns by 1 over n. So you find the mean. That's your average. Step 2, compute the deviation. I'm going to get different colors going here. So we get the deviation, which is just the return minus the mean. So here we have, we've got n returns. So we've got, 4 returns, let's say. You've got The first return minus the average, that's the deviation. The second return minus the average. Third return minus the average. Fourth return minus the average. So subtracting out the mean is the deviation. If, let's say the mean's 5% and the return in the first year was 8%, 8% minus 5%, 0.03, 3 percentage points. Let's say the second year the return was 0, 0 minus 5, negative 5. So the deviation captures how each individual return compares to the mean. Deviation, difference. Step 3, square each deviation. And again, the reason we want to square them is we're going to have some deviations that are negative if the, we'll have some deviations that are negative if the actual return is less than, or the return that actually took place is less than the mean, or it'll be positive if the actual return that took place is greater than the mean. And all we're interested in is the magnitude of the difference. How much does the returns that we see tend to differ from the mean? So, square it. In step 4, we want to find the weight for the variance. So this is where there's a little bit of a wrinkle. And there's a statistical penalty that gets imposed, and that is the weight for the variance is 1 over the number of returns minus 1. So that's why in the equation you can see what we're doing is we've got n of these returns. We gave a little example where there was 4. Each one gets a weight of 1 over n minus 1. So if there's 4, each of them will get weighted by 1/3. And step 5 is you've got your weights, you've got your squared deviations, you just go ahead and find the variance. And notice another way you can do it is add up all of the squared deviations and then divide it by n minus 1. What is standard deviation? It's just the square root of variance. So you get variance, you take the square root of that, and you get standard deviation. There's a lot of things you can do with standard deviation if you assume a normal distribution. It gives you information on the likelihood of particular outcomes happening. And standard deviation, again, it's the tendency of an asset's returns to deviate from the average return for the asset. So again, if you've got the average, the returns for any individual year tend to be similar to that average, in which case you've got a low standard deviation, or they tend to bounce around a lot and be quite unpredictable, real high one year, real low the next. There you would have a higher standard deviation. And so when we talk about the estimated standard deviation or the estimated variance from a sample, that's called the sample standard deviation or the sample variance. That means we've got a sample, a finite number of actual observations of returns, and we want to use that information to estimate the standard deviation or the variance. We use the techniques that we've just talked about as far as finding the variance, where you weight everything by 1 over n minus 1, and the standard deviation is the square root of that.